Have you ever wondered if it's possible to communicate across vast cosmic distances instantaneously? It may sound like science fiction, but the bizarre phenomenon of quantum entanglement could hold the key to achieving this feat. Quantum entanglement is one of the strangest and most counterintuitive concepts in physics. It describes a situation where two or more particles become inextricably linked, even when separated by vast distances. The behavior of these particles is entangled, meaning that measuring or altering the state of one particle instantly affects the other, regardless of the distance between them. This phenomenon seems to defy our classical understanding of the universe, where information cannot travel faster than the speed of light. However, quantum entanglement does not actually transmit information. It simply creates a correlation between the particles' states. While quantum entanglement itself cannot be used for instantaneous communication, as that would violate the laws of physics, some researchers have proposed using it as a resource for communication protocols that could potentially transmit information faster than classical methods. One idea involves using entangled particles to establish a shared random key for encrypting and decrypting messages. By exploiting the quantum properties of these particles, it might be possible to detect any attempt at eavesdropping, ensuring secure communication over long distances. Another intriguing concept is quantum teleportation, where the precise state of an atomic particle is transmitted from one location to another with the help of classical communication and previously shared entangled particles. While not instantaneous, this process could potentially enable faster-than-light communication over vast distances, provided the necessary resources are available. However, there are significant challenges and limitations to overcome before we can achieve practical instantaneous communication across galaxies using quantum entanglement. Firstly, maintaining entanglement over vast cosmic distances is extremely difficult due to the fragile nature of quantum states and the presence of various sources of decoherence that can disrupt the entanglement. Secondly, the amount of resources required for establishing and maintaining entanglement over such distances is currently beyond our technological capabilities. Lastly, there are fundamental questions about the interpretation of quantum mechanics and the role of measurement in the entanglement process, which could impact the feasibility of using entanglement for communication purposes. While the idea of instantaneous communication across galaxies using quantum entanglement may seem like a far-fetched dream, the mysteries of quantum mechanics continue to intrigue and inspire scientists.